Hello everyone, welcome back to Diksha Karnataka YouTube channel. And if you are currently studying in second PU, that is second year of your PU exam, then you should know that Department of PU Education has released 3 different model papers for each subject including physics. So today I am going to discuss about the second model paper. I have already completed the first model paper. If you have not checked that video, you can search in our channel Physics Model Paper 1 for PU2. You will find that video in our channel, and today I am going to discuss about the solution for model paper number 2. Now if you search in the internet for questions that is there in your PU second model paper question paper, you will find a lot of different answers. Some of them are incorrect, some of them are correct, so you cannot trust which of them is correct. But as usual, here we are always providing you with the correct solution for all types of questions. So here as well I am going to provide the solution for all the questions that came in the second model question paper. So without further delay, let's start with today's lecture. So first obviously we will go through the MCQ sections, then fill in the blank section, then 2 marker section, then 3 marker section, finally 5 marker derivation questions, and then 5 marker numerical questions. All questions we are going to solve in this class. So the total electric flux through a closed surface in air is equal to 1 by epsilon times the total charge enclosed that of the surface. This is the statement of. We know that 1 by epsilon naught comes only in one the theorem, that is Gauss's law of electrostatics. So Gauss's law of electrostatics is the correct answer. We can easily answer this without much thought. So option C is the correct answer. Now the electric potential due to a negative point charge at a distance r is positive and it varies with 1 by r square, positive and it varies with 1 by r, negative and it varies with 1 by r square, negative and it varies with 1 by r. So charge is negative, okay, and electric potential due to a charge is basically given by kq by r, right? For normal charge, single positive charge, it is given by kq by r. Now here they have said that the charge is negative, so V negative will be minus kq by r. Why minus? Because charge itself is negative, so that negative sign will reflect in the symbol, so it will be negative and it varies with 1 upon r, right? So this is the answer. Slightly tricky but not super difficult. Now let's see the question number 3. Identify the wrong statement from the following. The drift speed acquired by free electrons per unit electric field is called mobility. That is the definition of mobility. So definitely it is a correct statement. Now you have to identify the wrong statement. Very careful. So 3 statements are correct, only 1 statement is incorrect. So you have to read all the options properly before answering. The conductivity of semiconductors decreases with the increase in temperature. So conductivity of semiconductors, we know that as we increase the temperature, it becomes a better conductor, so its conductivity increases. Okay, so conductivity increases with increase in temperature. So as so whatever we have read, this appears to be the candidate. Let's read other 2 options as well. The conductivity of conductors decreases with increase in temperature. Yes, this is the correct statement. As we increase the temperature, the electrons start oscillating with the higher frequency and they collide with each other. That increases the resistance, and increasing the resistance means conductivity decreases. Alloys are widely used in the construction of standard resistors. This is slightly uncommon, but actually this is correct. Okay, alloys are widely used in different kinds of resistors. For example is nichrome wire. Nichrome wire is used in the resistors that you use in your laboratory. So definitely this is a correct statement. So A, C and D are correct statement, whereas B, as we have found out, was incorrect. So the correct answer for this question will be option B. Now question number 4. Here is a matching question, and all the 3 model papers has at least 1 matching MCQ. So you can expect at least 1 match the following kind of MCQ, right? So the physical quantities are related to magnetism are listed in column 1 and the dimensions are listed in the column 2. Identify the correct match. So how to tackle such kind of questions? To tackle such kind of questions, as I always say, first you have to match whatever you know. Unknown ones will match automatically. Okay, so for example, magnetic moment, I know it is matching with L square A. So basically 3 is obviously B. Okay, so 3 will definitely match with B. So this much I know already. So as soon as I can see one identifiable matching, we will do the matching as immediately possible. Okay, now magnetic field is given by m t to the power minus 1 a to the power minus 1. Okay, so magnetic field will match with option C, and magnetic permeability is basically same as magnetic field, only 1 extra ampere in the division. So magnetic permeability will be option A. Okay, so 1 is matching with C, 2 is matching with A, and 3 is matching with B. Okay, now if you see only that is also a trick, that in this case we said that magnetic moment is matching with B, so only one option in this given case is actually matching with 3. So 3B is the correct match. As we know, this is our known matching. Even if you don't know about A and C, so you can say that okay, I know this is correct, this much is correct, so I can find this is the correct match. So definitely no matter whatever other matches are, so this is the correct answer. So option D is the correct match, right? So the other match will automatically follows you. So don't worry, even if you are not able to match, try to match at least once. Next see what are the possible matches, and then you can decide. Now question number 5. The ferromagnetic material among the following is copper, nickel, lead, calcium. So we know that ferromagnetic material is nickel, iron, cobalt, nickel, they are considered to be ferromagnetic material, along with gadolinium. Gadolinium is something which switch between ferromagnetic and paramagnetic at room temperature. Okay, so gadolinium at 0 degree Celsius is a ferromagnetic example. Okay, so nickel is a common ferromagnetic material, right? Now next question, the following are the statements related to self-inductance. What are the statements? The self-inductance of a coil depends on its geometry and the permeability of the medium inside it. The self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. So basically second statement is, we know it's correct. First statement in fact is also correct. Okay, it depends on the geometry of the coil because basically it depends on the area. It also depends on the permeability of the medium, mu of the medium. So that is also correct. Both statements are correct. Okay, both statements are correct. So option C is the correct answer for this question. Now next question, question number 7. In a transformer, NP and NS are number of turns present in its primary and secondary coils respectively. The transformer is said to be step up transformer if. So step up transformer means when the number of turns in secondary is more than that of number of turns in primary. That is the primary condition for a step up transformer. Now let's see what is the given option. So as we can see from the given option that NP is less than NS. So if you reverse it, NP becomes less than NS. So that is the correct answer, right? So option A is the correct answer. Question number 8. The expression for displacement current. So expression for displacement current is ID equals to epsilon naught d phi e dt. Okay, so ID equals to epsilon naught d phi e by dt. Now you have to remember that this mu naught comes from the fact of Ampere's law. Ampere's law says that B dot dl is equals to mu naught I, right? If you apply the current ID in here, then you get this mu naught I epsilon naught. So don't get confused. ID is only epsilon naught. It is related to electric field. So that is why it is epsilon naught. If it was related to magnetic field, then maybe mu naught. But displacement current is due to the variation of the electric field associated between two plates. Okay, or between some gap. So electric field, electric flux, electric field, so associated is with electric flux. So basically that is why it is epsilon naught. Be careful, don't fall for the trap. Now question number 9. Identify the statement which is true for a compound microscope from the following. So we have to identify true statement. That means 3 of them are incorrect, only 1 is correct. Its objective is a convex lens of greater aperture. Eyepiece is a convex lens of smaller aperture. The image formed by its objective is real and inverted. The eyepiece produces the final image, which is virtual and diminished. Okay, so eyepiece does not produce a virtual image which is diminished. Okay, eyepiece produces enlarged image. That is why we see bigger image, right? The image formed by its objective is real and inverted. Now generally the size of the objective lens in a compound microscope is smaller compared to eyepiece. Okay, so if you have seen the diagram given in your textbook, the size of the objective is smaller compared to that of eyepiece. Okay, so that is why first two statements are incorrect. Now during my live session, when it went live in the ray optics chapter, I gave you an incorrect answer. Sorry for that. The correct answer will be image formed by its objective is real and inverted. So image formed by the objective lens is real and inverted. It is not the first one, objective of the convex lens greater aperture. No, it is basically the image formed by the objective is real and inverted. Okay, so those who answered it correctly, congratulations to them. Now let's see the question number 10. Diffraction effect is exhibited by only sound waves, only light waves, only matter waves, all types of wave. So diffraction is a property of wave. As long as it's a wave, it will show diffraction property, no matter what type of wave it is. So basically it is a property of all types of waves. Now in photoelectric effect experiment, if only the frequency of the incident radiation is increased, then the maximum kinetic energy of the photoelectrons decreases, the stopping potential increases, the photoelectric current increases, the photoelectric current decreases. Now obviously you know that the frequency h nu is equal to or you can say that not h nu, let me write it in a better form. The kinetic energy, maximum kinetic energy, the kinetic energy max is basically h nu minus phi. Okay, phi is the work function of the material, right? Now as you can see, if you increase the nu, okay, kinetic energy will increase. Okay, because phi is a constant, so if you increase nu, h nu increases, that means the difference is increasing, that means the kinetic energy is increasing. Now photoelectric current does not depend on the frequency. Yes, it has to be more than the level of the threshold frequency, but other than that the saturation current is independent of the frequency. Saturation current is dependent on the intensity of the light, right? But kinetic energy, stopping potential, they are dependent on the frequency. Now this is also the stopping potential. You can also calculate this kinetic energy max. It can be written as EV. Okay, V is the stopping potential. So stopping potential increases. If you increase frequency nu, stopping potential will also increase. So the stopping potential increases is the correct answer for this question. Now let's move on to the next question. The impact parameter is minimum in alpha scattering experiment for the scattering angle of. Minimum means when it is going to the closest to the nucleus, right? So scattering impact parameter means when it is going straight towards the nucleus, and if impact parameter is minimum, after it reaches to this distance, it reflects back directly. That is giving you a scattering angle of 180 degrees. So for 180 degree the impact parameter is minimum. Okay, for the scattering angle 180 degree the impact parameter will be minimum. That is, it is going straight towards the nucleus. Going straight towards the nucleus means it will come back exactly the path through the path which it followed. So definitely it will be 180 degree deflection. Next question, the standing wave pattern of a matter wave associated with an electron revolving in a stable orbit is shown in the diagram. Okay, the principal quantum number n and the radius rn of the orbits are respectively. So I think the diagram is missing in this question. So it will be nh by 2 pi and whatever is the diagram given, based on that we have to answer it. Now this question I will be answering in the live session as well, so that time I will bring the diagram. For now I am skipping this question because the diagram is somehow missing in this question. Now question number 14, radioactive decay in which very high energy photons are emitted are called. So high energy, there are three types of decay in radioactivity. One is alpha decay, next is beta decay, and third is gamma decay. Alpha, beta both are particle decays, nothing too related with the photon decays. Photon decay happens only when gamma radiation is emitted and it has very high energy. So high energy photon, obviously gamma decay, nothing with alpha decay or negative or positive beta decays. Okay. Now, when a forward bias is applied to a PN junction, it rises the potential barrier, reduces the majority carrier to 0, lowers the potential barrier, rises the width of the depletion region. So when a forward bias applied means the depletion region decreases, that is the barrier potential decreases, right? So it decreases or lowers the potential barrier so that electron can pass, holes can come, so the mixing process starts, so it can conduct electricity. That is why it is called forward biased. So forward bias means potential barrier decreases. Now let's move on to the next part. So the magnetic susceptibility is negative for dash material. So this is the fill in the blanks. So you have to check all the options given: 0 paramagnetic, transverse, AC generator, 1 diamagnetic. So from the given options we can see that either the answer will be paramagnetic or it will be diamagnetic. No other answers are possible. So now let's see. The magnetic susceptibility is negative for dash material. So magnetic susceptibility is negative for one of them and positive for other. Right? Now if you remember, paramagnetic is basically positive susceptibility. That means diamagnetic will be negative susceptibility. So you have to be careful answering this question. Next, 17, the device which works on the principle of electromagnetic induction is. Now let's see the option. 0 paramagnetic, diamagnetic is already gone. Diamagnetic, in fact we have already answered it, so this is crossed. Now paramagnetic is obviously not a device. Now transverse is not a device. Only device that is given here is an AC generator. So the answer will be AC generator. As we can see, only one device is given in the option, so that device directly matches here. The power factor of an AC containing pure resistor is. So power factor of an AC, now in this case this will be a number, so only two numbers are there, 0 and 1. Now power factor with pure capacitor and pure inductor are 0, but for pure resistor it is 1, right? So the answer for this will be 1. The light waves are dash in nature. So if you see 0, so these are all answered. AC generator already we have answered, 1 is already answered. So what are all the options left for this? Either 0 or paramagnetic or transverse. Now paramagnetic definitely will not going to have, so light waves are transverse in nature. So light waves are transverse in nature. Last but not the least, the charge of a photon is. The photon is a chargeless particle, it has no charge, so photon will have a 0 charge, so 0 charge is the answer. Now let's move on to the 2 marker section. The charges are additive in nature, explain. So let's see what is the meaning of this. If a system contains 2 point charges Q1 and Q2, the total charge of the system is obtained simply by adding them algebraically, that is Q1 plus Q2. That is, the charges add up like real numbers or they are scalars like the mass of a body. So that is the main thing that you have to explain in this part. What is the meaning of charges are additive in nature? So charges are additive in nature means you can simply add them like scalars. For For example, if two charges Q1 and Q2, no matter whatever is the polarity of the charges, it will always give you can simply add them. That is the meaning of additivity of charges. Now you have to give one example in this case. So for example, the total charge of a system containing 5 charges, I have taken 5 charges. You can take any number 2, 3, 4, 5, not take 2, do not take 2 charges, 3, 4, 5, anything is fine. Okay, containing 5 charges, plus 1, plus 2, minus 3, plus 4 and minus 5 in some arbitrary unit. Okay, maybe in coulomb, you can mention coulomb also. Then total charge is plus 1 plus 2 plus minus 3 plus 4 plus minus 5. So if you see that minus sign we have kept in a bracket to glorify that this plus is basically is more important. So charges are adding, the negative charges will be added with the sign. Now if you add everything, you will get the minus 1 as the charge in the same unit. So this is the example. You can give any one of the examples. Okay, this is the example. I think I took it from your NCERT book, so that is why the example looks like this, but you can take any examples containing 3 charges. That is fine. Now let's move on to the next question. What is an equipotential surface? What will be the shape of the equipotential surface corresponding to a single point charge? Let's see. Any surface which has a same electric potential at every point is called equipotential surface. The shape of a equipotential surface is spherical for a single point charge. So the single point charge, if you consider the shape of the equipotential surface will be spherical, because it will have a symmetry, right, radial symmetry, so it will be a spherical in nature. Okay, now, next question. Give any two differences between current and current density. Let's see the differences. So current is basically defined as the amount of flow of electric charge per unit time. Okay, the current density is the amount of current per unit area. Very important, it is current per unit area. The unit of current is ampere, whereas unit of current density is ampere per meter square, or ampere meter to the power minus 2. A moving coil galvanometer gives a deflection of 10 divisions when 200 microampere current is passed through it. Find the current sensitivity of the galvanometer. So how to find the current sensitivity? So current sensitivity is basically given by that number of division divided by the current for that division. Okay, and its unit is division per ampere. So what we have to do, one divided by 20 microampere, right? Micro means 10 to the power of minus 6 division per ampere. Okay, or this 10 to the power of minus 6 will go up, so 10 to the power of 6 divided by 20 division per ampere, or what you have to do, you have to divide this 10 to the power of 6 in two parts. One is 100 and another will be 10 to the power of 4. So I can write it like that, right? Divided by 20. Why did I do that? Because 20 into 5 is 100, so division per ampere. So current sensitivity is basically equals to 5 into 10 to the power of 4 division per ampere. This is the current sensitivity. So be careful, you have to use the proper unit, and unit is division per ampere. If you remember the unit of current sensitivity, you can answer. For voltage sensitivity, division per volt. Okay, that should be the unit. Next question, state Faraday's law and Lenz's law in electromagnetic induction. Okay, only statement they have asked, to only statement we will give. Faraday's law is time rate of change of magnetic flux through a circuit is equal to the induced EMF in it. Now Lenz's law, the polarity of the induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux that produce it. Okay, so this is the definition of Lenz's law, and if you combine them, we know that epsilon equals to minus d phi by dt. Okay, and the negative sign comes from the fact that Lenz's law says that it opposes, that is why the negative sign comes, and Faraday's law says it is equal, so equal means that is why equal sign is coming, right? So both law has their own purposes. Now another question, name the electromagnetic waves used for the following applications: the radar system used in aircraft navigation, the remote switches of household electrical devices such as TV. So microwaves are used for radar system and infrared waves are used for remote control of your TV. Now, how is the total energy of an electron revolving in an orbit of hydrogen atom related to the principal quantum number of the orbit? What is the significance of the negative sign in the expression for the total energy of the electron in hydrogen atom? So the expression for energy is given by En is equal to minus 13.6 divided by n square eV. Okay, it is in electron volt. The energy required to remove the electron to free the electron from the atom, that is ionization energy, must be supplied to overcome this negative energy. The electron is in stable orbit. So these are the 2 points. Any one point you can write about the negative sign. So negative sign represents basically, if you want to remove the electron from the orbit, then you must make this negative energy to be 0. Okay, so that is the one point. So or the second point is the negative sign represents that the electron is bound to the nucleus. Okay, so electron is bound to the negative nucleus. So a negative total energy signifies that the electron is bound state rather than being free. So if they are free, the energy will be positive, but because electrons are bound to the nucleus, that is why the energy is negative. Any free electron not in an orbit, they generally has a positive energy, right? Now, what is the intrinsic and extrinsic semiconductors? Very common question. So intrinsic semiconductors are pure semiconductors called intrinsic semiconductors. The presence of charge carriers, electrons and holes in an intrinsic semiconductor property of the material, and these are obtained as a result of thermal excitation. So intrinsic semiconductor is basically equal number of holes and electrons, and it can be obtained only by thermal excitation, that is heating, right? And it's a pure semiconductor. Whereas extrinsic semiconductor are the number of charge carriers can be changed by doping of a suitable impurity in a pure semiconductors. The such semiconductors are known as extrinsic semiconductors. There are two types of semiconductors, p type and n type. Okay, so extrinsic semiconductor is basically when you dope a pure semiconductor with impurity to increase its number of charge carriers. Okay, so you can either induce more extra negative charge carriers called n-type semiconductors, or you can induce more holes and you can make p-type semiconductors. Now question number 29. From here on we will see 3 marker questions. What is an electric dipole? Define the electric dipole moment, give its direction. Okay, not the unit. So dipole is the two equal and opposite charges separated by a small distance is known as electric dipole. The electric dipole moment is the product of magnitude of one of the charges and the distance between them is it's a vector quantity. The direction of a dipole moment is from negative to the positive charge, right? What is the capacitor? Mention any 2 factors in which the capacitance of a parallel plate capacitor depends. Okay, so capacitor is an electric device used to store charges, right? So capacitor basically the device which is used to store charges. Capacitance of a capacitor directly proportional to the area of the plate, inversely proportional to the distance between the plates, directly proportional to the dielectric constant between the plates. So we know that capacitance is basically given by C equals to K A epsilon naught by D. Right, this is the expression for capacitance, parallel plate capacitor. So it is directly proportional to K, directly proportional to A, inversely proportional to D. In case you forget, you can remember this equation and you can write the answer. Derive an expression for angular frequency of revolution for a charged particle moving perpendicular to a uniform magnetic field. So suppose we have a uniform magnetic field like this into the page of the paper, and we have a charged particle which is rotating in a circular path. Okay, now when it is orbiting, try to draw the circle better than me. Okay, so if it is orbiting in a circular path, there will be some angular velocity, say omega. Okay, and at this point there will be a linear velocity v. Okay, the charge say q, the magnetic field say b. Then whenever it is rotating in a circular path, what force it requires to maintain its circular path? Only one force is required to maintain circular path, that is centripetal force. And what is the formula for centripetal force? The formula for centripetal force is basically mv square by r. Now this is a force which has to be supplied by some external agency. Okay, it is required. This is the minimum force you have to have. This is the amount of money that you have to have when you are going somewhere. But where you will get that money? It will be provided by someone. For example, your father, mother, or your grandparents. Someone will give you the money. Now you can go to the shopping mall. You can go and play some games there, right? So this is the amount of money that required for an object to continue in the circular path. Now in this case, this force is basically provided by the magnetic component of the Lorentz force, that is QVB. QVB sin theta, but they are perpendicular, so sin 90 is 1. So QVB is the required force. So centripetal force and this force must be equal. So basically, as we said, that this force has to be supplied by some external agency. So this external agency in this case is the magnetic field that is providing the required centripetal force. So now you can cancel one of the V's. So from here you can calculate what is the value of V. So V equals to Q B R divided by M. Right? Now the question is not about finding the required velocity. The question is find the angular velocity. So how can we find the angular velocity? So we know that linear velocity equals to r omega, where omega is the angular velocity. So what we have to do, we have to supply this value, or we have to rather substitute this value. Okay, so these are cancels, so you get omega equals to QB by M. So basically it is independent of the radius, it only depends on the magnetic field, charge and the mass of the particle, right? So this is the expression for angular velocity. So if you do this derivation with this diagram, definitely you can get 3 marks, easy derivation, not super hard. Mention any 3 properties of magnetic field lines. Very common question. So the magnetic field lines of a magnet form continuous closed loops. The tangent to the field line at a given point represents the direction of the net magnetic field B at that point, and the magnetic field lines do not intersect, for if they did, the direction of magnetic field would not be unique at that point of intersection, right? These are all the common points we already know, we have already studied it multiple times. Now let's see question number 33. A horizontal straight wire 10 meter long is falling with the speed of 5 meter per second at right angles to the magnetic field 0.3 into 10 to the power of minus 4 Weber per meter square. Find the instantaneous value of the EMS induced in the wire. So what is the formula for instantaneous EMS? It is BVL. As simple as that. If you identify this formula and apply this, you will get full marks. Okay, so B is given by 0.3 into 10 to the power of minus 4. Many students just are afraid of solving questions, but you have to remember the formulas, then you can use. V is speed, that is 5 meter per second, and L is the length, that is 10 meter. Okay, so just do it. So you'll get this is the EMF volt. So just use it. 10 into 0.3 is 3, 3 5s are 15. So 15 into 10 to the power of minus 4 volt. okay, or 1.5 millivolt. This is a fancy answer, but you can keep the answer at this line also, you will get full marks. Okay, so just one liner question, and just for knowing the equation and just for having the courage to solve such questions, you are getting 3 marks, right? So these are the easiest question. So derive the relation between radius of curvature and focal length in case of a concave mirror. So this is one of the common derivation that we can expect in our exam. So first of all, you have to draw a concave mirror like this. There is a principal axis. Now we know that, so suppose this is the focus F, this is the center of curvature C. Now we know that when a ray parallel to the principal axis falls on the mirror, it passes through the focus for a concave mirror, right? It passes through the focus. So this is the ray diagram that we have to use. Now what else? We have to use that the fact that if we join this point and center of curvature, so center of curvature is basically the line. If you join it with the point of reflection, it is tangential to the line, right? That was there was a theorem we have learned. That means it is basically acting as a normal. So acting as a normal means this angle is theta and this angle will also be theta. Angle of incidence equals to angle of reflection. So this is the angle of incidence, this is the angle of reflection. So these two angles must be equal. Now what else we have to do? We have to draw a perpendicular from this point towards the base. Okay, so let's say this is the perpendicular. Now we have to name it, say sorry, this is the pole O, okay, and say this is N, any point N, okay, and any other points we need to name. I don't think we have to name any other point. Okay, so we have to name this point as well. This point is M. Okay, so these are the important points that we have to mention in our ray diagram. Ray diagram is compulsory for this derivation. Okay, now what else? So this is a parallel to the principal axis and this is a bisector, right? So parallel rays, bisector. If this angle say X, then this angle will be also X, right? We have learned it in our past. Now if you see, this is parallel to principal axis. This angle is, what is the angle? This angle is theta plus theta, that is 2 theta. So this angle will also be 2 theta, right? And this is the, again this is the parallel line and this is the bisector now. So this is the bisector, means this angle is now theta. So this angle will also be theta. Okay, so two lines, two different bisectors through different angles. Okay, so for this angle it will be equals to this angle, for this angle it will be equals to this angle, right? So two different, based on the bisector we can change the angles, right? So easy question, easy thing. Now you have to remember that the rays that we are considering, this ray say A and this ray say B, okay, AM and MB, it is considered to be a paraxial ray. What is the meaning of paraxial ray? Paraxial ray means, suppose this is the mirror, paraxial ray means the rays are very close to the pole. The rays are very, very close to the pole, even though here it appears to be slightly distant, but in reality, in practicality, it is basically very close to the pole of the mirror, so that we can approximate this distance to be 0. So ON is basically equals to 0. So if I say Cn, so Cn is basically same as CO, or Fn is same as FO. Then why do we need this line? Because to apply the principle of triangle. That is why we need a triangle. That is why we will draw this line. But then after drawing it, we will say for paraxial ray, we can ignore it and we will say that whatever this distance Cn, the same distance is equals to CO. That is the trick in this derivation. Now we will first consider the triangle MFN. So for the triangle MFN, okay, we will try to find tan of the angle that we have we have calculated. So this is 2 theta, so we will find tan 2 theta. Again, in this case, for this triangle, we will find tan theta. So what is tan 2 theta? Tan theta means perpendicular by base, right? So perpendicular by base. So tan 2 theta is basically mn divided by fn. Right now, what will be fn equals to for paraxial rays? For paraxial rays, first we have to write fn, then we have to write for paraxial rays fn will be equals to fo. Therefore, tan 2 theta also and tan 2 theta nearly equals to 2 theta, right? So for small angles, we know that sin theta and tan theta, they gives you the value of nearly equals to theta, right? So that fact also we have used, that because it's a paraxial ray, the angle of incidence, value of the angle of incidence is very small, and thus we can say that tan theta will nearly be equals to 2 theta. So 2 theta equals to mn divided by fo. Now what is fo? Fo is basically focal length, so mn by f. So this is the equation 1. Now from the triangle CMN, okay, tan theta equals to, tan theta is what? Perpendicular by base, that is mn by cn. mn by cn. Don't make any mistake with the diagrams. There are a lot of books showing different diagrams, and students often get confused. If you are confused, don't attempt this derivation. Okay, this is a simple derivation, but some sort of approximation is required. Again, for paraxial rays, you have to write the same line, theta equals to mn by co. Now what is co? Co is nothing but the radius of curvature, so that is r. Right now, if you put this value into the value of theta in the previous case, what you will get? You will get 2 into mn by r. So we are replacing this 2 theta with this equation, equals to mn by f, right? So mn cancel, so you get f equals to r by 2. Just take the reverse, so f equals to r by 2. This is the relationship between focal length and radius of curvature. So slightly longer in my opinion for a 3 marker question, but you cannot give this derivation as a 5 marker as well. So it is basically a 4 marker kind of question, but there unfortunately there is no 4 marker available in your board exam, so they have given it as a 3 marker question. Now give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. So let's see the Einstein suggested that each photon of a light has energy proportional to its frequency nu given by E equals to h nu, where h is the Planck's constant. When the light shines on a metal surface, photons transfer their energy to the electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electrons. So these are the main 3 points. Now photoelectric equation of Einstein is given by h nu is equal to 5 plus half mv square. Okay, so h nu is the energy that you supply, phi is the work function, and half mv square is the kinetic energy, right? So you have to mention that h is Planck's constant, nu is frequency of the incident light, phi is the work function of the metal, m is the mass of electron, v is the velocity of the ejected electron. Okay, simple. Now next question. Define binding energy and mass defect, write the relationship between them. Easy question. So a mass defect is basically given by the energy required to separate a nucleus into its nucleons is called the nuclear binding energy, EB. So the energy that you have to give it to the nucleus to make it disperse. Okay, binding energy on the other hand is the difference in mass of the nucleus and its there is a mistake here. Binding energy, this is the binding energy, this is mass defect. Okay, so mass defect and binding energy are got exchanged. Okay, sorry for that. The difference in mass of the nucleus and its constituents delta m is called the mass defect. Okay, this is delta m. Now delta m is given by Zmp plus A minus Z Mn minus m. So Zmp is the mass of the protons, A minus Z into Mn is the mass of the neutron, m is the mass of the nucleus itself. Okay, the relationship between them is Eb equals to delta m c square. So they are obviously related, binding energy and mass defect. Whatever mass defect is there, if you convert that mass defect into energy, that gives you the binding energy, and if you divide it by the number of nucleons, you get binding energy per nucleons. Now we are here into the 5-mark derivation part. Obtain an expression for potential energy of an electric dipole placed in an uniform electric field. So this is a 37A. So we have electric dipole, okay, say minus q and plus q placed in an electric field, say E. We are trying to find the potential energy. Okay, so how to do that? First of all, we have to see what is the torque acting on this. So torque acting on this system is basically given by Pe sin theta, right? If you remember P cross E, so torque, if you express it in the scalar form, then basically it gives you torque is equal to Pe sin theta. Now what is the potential energy? So potential energy is basically when you, if you remember potential energy in normal force, work done, force, in case of force, okay, so the potential energy was given by F dot dx integration, right? That was a potential energy, that is total work done. Potential energy is equals to total work done. Now here also it will be same, but since we do not know force, we know torque, so the equivalent instead of dx it will be d theta. Okay, as simple as that. Now you have to say initial angle is theta naught, final angle is theta. Okay, so the potential energy will be Pe will be common integration theta naught to theta, okay, sin theta d theta. Okay, so it will be Pe. What is the integration of sin theta? Integration of sin theta is minus cos theta. Right, cos theta's differentiation is minus sin theta, so sin theta's integration is minus cos theta, theta naught to theta. You can take this minus outside, so minus Pe cos theta minus cos theta naught. Okay, this is the general expression. Now we take theta naught to be 90 degrees, a position of equilibrium, right? So if they are in the 90-degree angle, then at that point you can consider the potential energy is 0, obviously. So in that case the potential energy becomes minus Pe cos theta, or it becomes minus P dot E. This is the derivation for potential energy. Easy derivation, very simple step-by-step derivation. If you follow the step-by-step process, you can answer it. Okay. So this is the, just a second, let me correct it. So we say that potential energy is basically 0 at theta is equal to 90 degrees, so U equals to 0. Now here P is not potential energy, here P is dipole moment and E is electric field. That you have to mention in the solution. Now next question is, define the energy density of a charged capacitor. So this is a part question, so this is a longer question. You have to first derive that part, then that derivation I think had 3 marks. For this you have 2 marks for each part. Define the energy density of a charged capacitor, how the energy density related to the electric field present between the plates. So the energy density U of a charged capacitor is the energy stored per unit volume in the electric field between its plates. It is given given by U is equal to half CV square. We already know that the relationship between the electric field and the energy density is U is equal to half epsilon naught E square. So this is the relation. Now derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistance connected in parallel. So we have two cells, okay, one is this, another one is this, and they are connected in parallel. Parallel means they are connected like this, and we connect it through a external resistance, say capital R. Okay, this is the circuit. So this is epsilon 1, this is R1, epsilon 2, R2, right? And the equivalent circuit for this will be only one and only one, internal resistance only one, EMF source, but the external resistance will remain same. And if the current in the circuit, say, is I, the same current will be there in the equivalent case as well. Now current through individual cells will be different because they are connected in parallel, right? So they are connected in parallel, so individual resistances will be different, but they both of them will have the same potential across them. Okay, so that is the advantage of using parallel combination. Potential difference remains same, right? But in case of parallel combination, we know that in case of series combination, we know that current remains same. So basically, what is the voltage drop across this resistance R? Voltage drop across this resistance R is I into R, and that is same for both the EMFs. Now I into R is basically given by epsilon 1 minus I1 into R1, right? And I into R again will be equals to epsilon 2 minus I2 R2, right? This is the formula we know. These are the known formulas, right? So this is how we will start our journey. Now we also know that these two currents are getting merged into forming I. So I is basically equals to I1 plus I2. Okay, so what we will do, we will replace this IR equals to V for now, because this IR is not super important at this moment, but this is important. Okay, so what we will do, we will say V minus epsilon 1 not like that. So we will just organize it. I will show it for once, then I will erase it. So epsilon 1 minus I1 R1 equals to V, right? So we are trying to separate this I1 R1. So I am taking it on the other side, V is coming to this side. So epsilon 1 minus V equals to I1 R1. So I1 is basically equals to epsilon 1 minus V by R1. Okay, similarly I2 will be equals to epsilon 2 minus V divided by R2. Okay, so now what we will do, we will find the total current using this relationship. Okay, this relationship. So I equals to I1 plus I2, that is equals to epsilon 1 minus V by R1 plus epsilon 2 minus V by R2, or epsilon 1 by R1 minus V by R1 plus epsilon 2 by R2 minus V by R2. So now let's organize it. So epsilon 1 by R1 plus epsilon 2 by R2 minus V by R1 plus V by R2. Okay, you can take this V common. So this will become V into 1 by R1 plus 1 by R2. So V is common, 1 by R1 plus 1 by R2. Y plus negative sign is common now here, right? So this is the final equation. Let's name it, say 1. Now for the equivalent circuit, we have to find the similar equation for the equivalent circuit as well. So equivalent circuit again, V is equal to IR, right? Sorry. So V equals to IR for the equivalent circuit as well. And if you apply the same law, sorry, the board is disturbing a little bit, so that is why it's taking some time to erase these equations, right? Now, so let's see. So in the equivalent case, IR is the same, right? IR is the same, I into R. So I into R, that is V, I into R, we named this as V, that should be equals to epsilon equivalent minus I into R equivalent, right? Now if you see here, we have individually separated the current I. So if we try to do the same here as well, so what we have to do? So let's see. So IR EQ equals to epsilon EQ minus V, right? Or I equals to epsilon EQ divided by R EQ minus V by R EQ. So here also I is equal to some value minus V. Here also I is equal to some value minus V. Right, so if we compare the similar terms, we can say that EQ by REQ is basically equals to epsilon 1 by R1 minus epsilon 2 by REQ. Sorry, R2, my mistake. Okay, or epsilon EQ is basically, now we do not know the value of REQ. So what we will do, we will do it like this: epsilon 1 minus R1 epsilon 2 by R2 divided by 1 by REQ. Instead of multiplying it REQ in the top, we have divided it with a 1 by REQ symbol. Why so? You will realize once we start compare the second value, that is this and this one. Okay, so if you compare these two values, you will get that V minus V by REQ is equals to V in common. So V by REQ is equals to V into 1 by R1 plus 1 by R2. Okay, so this V cancel. So basically you can see that REQs are nothing but the parallel combination of resistances. So you can write 1 by REQ equals to 1 by R1 plus 1 by R2. So if you replace it here as well, you have to do that, by the way. Don't leave it with REQ in the expression, you have to do it by the way. So 1 by R1 plus 1 by R2. This is the expression for equivalent EMF. This is the expression for equivalent resistance. Slightly longer derivation, but can expect this kind of derivation as well. Series and parallel both are important. Now derive an expression for force per unit length of two infinitely long thin parallel straight conductors carrying currents, and hence define ampere. So we have two parallel currents, long parallel currents, okay, carrying current I, and we are trying to find the force. First of all, you have to consider a length, say L. Okay, we have to consider a length L. Right now, what is the magnetic field due to this wire at this point? Okay, say this is wire 1, this is wire 2. What is the magnetic field B1 at the location of 2? The distance between them is D. Okay, Ampere definition I will not give in this lecture. I have already given it multiple times, but I will tell you how to do that. But for now we will just concentrate on the derivation. So B1 is basically equals to, what is the formula? If you forget the formula, you have to remember it for a single wire. So this is a single wire carrying current. You can consider an Amperian loop of radius r. Okay, this is how you can remember. So B dot dl, integral B dl equals to mu naught I. Right, this is the current I. Now what is dl here? B is constant due to symmetry, so dl equals to mu naught I. Now what is dl? Dl is basically the circumference, that is the perimeter of the circle. Perimeter of the circle is basically 2 pi r. So B into 2 pi r. This is just a rough. You can do this in the rough, so that in case you just forget the formula, you can still use the values. It will be mu naught by 2 pi I by r. Okay, now this wire is carrying say current I1 and this wire say carrying I2. Then B1 will be mu naught by 2 pi I1 by d. Why d? Now here it was r distance apart, right? Here the distance is d, right? So instead of r it will be d. Don't confuse, because I have seen students, they often write d square over here. This will not be d square. So that is why I request, if you forget, you can apply the Ampere circuital law briefly and you can calculate the magnetic field. This is a very small easy derivation in case you forget, so that you can still do if by applying the Ampere circuital law. Right, now let's move on. So B1 is mu naught 2 pi I into d. Right, now suppose the current through this is I, right, and what is the current, what is the force acting on this wire? So force acting on this wire is basically given by BIL. Now in this case B to L. Now we consider a finite length, so that we can apply this formula. Later on we will divide L to cancel the L. Right, so B, we will put the value of B here, so that will be mu naught by 2 pi I1 I2 by d into L. Now similarly, this is the force on the second wire due to first wire. Similarly, force on the first wire due to second wire will have the same magnitude. Direction we are not sure at this moment, but the magnitude wise they will be same. Right, you can see the symmetry, so you can just say that by symmetry they will be same. So F is basically equals to F21 equals to F12 equals to mu naught by 2 pi I1 I2 by d into L. Now this is not done. This is the total force. Now you have to find the force per unit length. So force per unit length is basically F by L, that is mu naught by 2 pi I1 I2 by d. Okay, this is the force per unit length. Now how can you define ampere from this? So to define ampere, first of all you have to assume that I1 equals to I2 equals to 1 ampere. So both wires are carrying 1 amperes. Okay, and then distance between them is 1 meter. Okay, then if you see that F will be equals to mu naught by 2 pi. So what is mu naught? Mu naught is 4 pi into 10 to the power of minus 7 divided by 2 pi. So 2 pi and 4 pi will cancel. You will get 2 into 10 to the power of minus 7. Now this much force, okay, per unit length will act if two parallel current carrying wires carrying current 1 ampere each are separated by 1 meter, then they will experience a force of 2 into 10 to the power of minus 7 Newton per meter. Okay, so that is basically the definition of ampere. Okay, this part you have to remember. Next, move on to the next part. What is a wavefront? Explain the refraction of parallel plane wave through a thin prism with a neat diagram. So let's see the wavefront, definition of wavefront. So wavefront is an imaginary surface that connects points of a wave that are in phase, that is points that have the same phase of oscillation. It represents the shape of the propagating wave. So this is called wavefront. Let's see the wavefront for a plane prism. So when the light ray is incident on the prism, they are basically plane wavefront. Okay, so this is an incident plane wavefront, and as we know that after light falls on a prism, okay, it bends towards the base, and that is why after it falls on the prism, it bends, and the plane wavefront is now bent to an angle. Okay, there will be some obviously governing laws, but we are not interested in that. We can just need to draw the diagram, and you have to say that since the rays are bending towards the base, the wavefronts will still be parallel, it will still be plane wavefront, but it will be having a different angle than that of the incident wavefront. That's it. Next is give any two differences between constructive and destructive interference of light. So constructive interference occurs when two waves meet in phase, reinforcing each other. Okay, and destructive interference occurs when two waves meet opposite phase, cancelling each other out. Okay, results in a wave with higher amplitude and intensity. So intensity and amplitude both increases, results in a wave with lower or zero amplitude and lower intensity. If the interference is happening between two equal waves, then intensity will be zero, amplitude will be zero. But in case they have the intensity of the two waves are not same, then it will not be zero. Okay, that's it. Now let's see what is the half wave rectifier. Explain the working of a half wave rectifier using neat circuit diagram, and also draw the input output waveforms corresponding to it. So half wave rectifier is this. Okay, so as you can see, there is only one diode in half wave rectifier, and the input output diagram is this. So these diagrams are compulsory to get marks in this question, but this is a very common full wave, half wave. One of them will definitely come in your PU board exam. A half wave rectifier is an electronic circuit that converts alternating current into direct current by allowing current into flow only during one half cycle of the AC input signal. The other half cycle is blocked, so only half of the AC waveform is used. Next, positive half cycle of AC. During the positive half cycle of the AC input, the anode of the diode is positive with respect to the cathode. The diode becomes forward biased and conducts current. Current flows through the load resistor RL in one direction, and the voltage across the load is positive. Negative half cycle of the AC. During the negative half cycle of the AC input of the anode of the diode becomes negative with respect to the cathode. The diode is reverse biased and does not conduct. No current flows through the load resistor RL, and the output voltage is zero during this half cycle. Now let's solve the numerical questions. I have solved these numericals. Again, I am going to solve, and I am going to explain why you should not attempt solving numericals from current electricity based on the model question paper. Okay, 2 point charges plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in air. Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. So basically we have two charges. One is plus 4 nanocoulomb, another one is plus 8 nanocoulomb. We are trying to find the electric field at the line joining the 2 points at the midpoint. The general distance between the charges is 0.2 meter. So the half distance will be 0.1 meter. This will also be 0.1 meter. This is the first part. Second part, there is a second part to this question, is that what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is replaced by another plus 8 nanocoulomb charge. So if you replace this charge with another plus 8 nanocoulomb charge, what will be the force? What will be the field. Now how to find the field? So if you place a positive charge here, unit positive charge, what will happen to this charge? This plus 4 Newton will 4 nanocoulomb will repel in this direction, and this plus 8 nanocoulomb will repel it in this direction. Okay, now being greater charge, the force due to plus 8 nanocoulomb will be bigger and force due to plus 4 nanocoulomb will be smaller. Okay, so they are in opposite direction, so the resultant electric field will be equals to E8 minus E4. As simple as that, and the direction will be away from plus 8 nanocoulomb. Right, so first we will find the individual electric field. So E8 is equal to K Q, not Q, let me write the charge itself directly. K Q, that is 8 into 10 to the power of minus 9 divided by R square. R is 0.1 whole square. Okay, at the beginning you can just write the formula in one line, and then you can start from this value. So K is 9 into 10 to the power of minus 9, sorry, not minus 9, K is the savior. So K will be plus 9. 9 into 10 to the power of 9 into 8 into 10 to the power of minus 9 divided by 0.1 whole square means 0.01. Okay, so this will cancel. 72, not 72, 72, and this is divided by 0.01. Divided by 0.01 is same as multiplied by 100. Okay, so this is the electric field due to the E8. And what will be the electric field due to E4? Electric field due to E4 will be K into 4 into 10 to the power of minus 9 divided by 0.01. Okay, just same process, right? So 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9 divided by 0.01. So again it will be cancelled, and you will get 4 9s are 36, 100 Newton per coulomb. Okay, so what is the resultant electric field? So resultant electric field is basically 7200 minus 3600, that is 3600 Newton per coulomb. And this will be the resultant electric field for the first case. Now in the second part it mentioned that if you replace it with another plus 8 nanocoulomb, then what will happen? This will repel in this direction, this one will also repel in this direction, and because both of them are equal charge, they will cancel each other, so the resultant electric field will be 0. So you have to mention that in a sentence, that resultant electric field will be 0. So the answer is 3600 Newton per coulomb for the first part and 0 Newton per coulomb for the second part, right? Now let's move on to the next question. Now this is a complicated long question. Okay, even though the circuit seems simple, but you should not attempt numerical questions from current electricity chapter for your board exam. Okay, because they give random circuits which is sometimes very difficult to analyze and solve. So here we have a 4 volt 2 ohm circuit battery, and it is sending current in this direction. Okay, and here we have another battery 2 volt 1 ohm, and it is sending current in this direction. Okay, so here the resistances are 6 ohm, 10 ohm, 4 ohm. Okay, here the resistances are 2 ohm, 4 ohm and 10 ohm. Now I3 is basically at the junction. So I1 is entering from this side, I2 is entering from this side, right? So I3 is basically I1 plus I2. Right, that is a junction rule. Whatever current is entering, that should be equals to current exiting. So basically I3 is equals to I1 plus I2. Now here, as I always say, that through a battery, whatever current exit, the same current should enter. So I1 exit from this side, so I1 will only enter from this side. So basically that means this current is also I1, and with the same logic this current will be I2. So they are combining only when they are passing through this resistance, and then again they are separating their own path and they are going through their own individual path. Now first we will apply, we will go through this direction. First we will go through this direction. Okay, and A, B, E, F, A. So A, B, E, F, A in this direction. So what will be the first? We will start with this internal resistance. So internal resistance is 2, current through this is I1. So internal resistance can be considered to be a resistance in series with the battery, right? So in series with the battery means whatever current is passing through the battery, the same current should pass through the internal resistance as well. Okay, so you can simply imagine that 2 ohm is basically connected over here. This is the 2 ohm. With this 2 ohm you can consider it is connected like this. Similarly here the 1 ohm you can consider the 1 ohm is connected over here. Don't get confused with any other methods. This is the easiest method. Okay, now 2I1 plus 6I1. Why plus? Because we are going in the direction of current. 6I1, again we are going in the direction of current. 10I3. 10I3. Now what is I3? I3 is I1 plus I2. So instead of writing I3, I just skipped one step. While writing in the exam, you have to write I3 as well, and then you can write I1 plus I2. Now again we are going through the last resistor, that is 4 ohm. So 4I1, and that should be equals to the voltage of the source, that is 4 volt. Okay, now let's separate 2I1 plus 6I1 plus 10I1 plus 4I1 plus 10I2 equals to 4. So all I1s are together and this I2 is separated. So it will be 8 plus 4, 22, 8 plus 4 is 12, 12 plus 10 is 22. So 22I1 plus 10I2 equals to 4. Now we can divide every number by 2. So 11I1 plus 5I2 equals to 2. Right? This is the first circuit. This is the equation 1. Now we will use the equation 2. So what is, how to do that equation 2? Now we will go in this direction. Now it is generally we are breaking out one of the principle, but because they are two individual cells and they are sending the currents are also in the direction of the cells as shown, I can use this same logic here as well. And we are going because, and if you are doing the same way, so for example if you are doing this and this, then this all the terms in this case will be negative. To avoid that, what we will do, we will go in the direction of the current sent by the battery, and in we will apply our logic. Okay, so current is passing through here. So first is this internal resistance 1I2 plus next is this 6I2 plus next is this, again we are going in the direction of current, so 10I3. 10I3 means 10I1 plus I2 plus last resistance 4I2, and that should be equals to the EMF because we are going in the direction of the battery. So 1I2 is basically I2, so I2 plus 6I2 plus 10I2 plus 4I2 plus 10I1 equals to 2. Okay, now you add them. 6 plus 1 7, 7 plus 10 17, 17 plus 4 is 21. Okay, so the values are very very bad, you cannot simply solve it. Okay, so this is equation number 2. Now I want to eliminate I2 from these two equations. I2 has the simplest elimination method, so we will try to find I1 from this. So what we have to do, we have to multiply 21 with 11. So first we will we have to multiply this 5 with this all the numbers and this 10 with all these numbers. So what we will get? First 10 I1 plus 50 I2 equals to 20. Right, we multiplied with 10. Next is we multiply with 5 for this number. So 5 into 21 is 105. One more thing, I made a mistake here. this is I1, right? So that equation is incorrect. So 21I2 plus 10I1 equals to 2, or 10I1 plus 21I2 equals to 2. So to cancel this, what we have to do, we have to multiply. It is easier for me to eliminate I1. It is easier for me to eliminate I1 because this is 11, this is 10, so I can eliminate them. So how can I do that? So first we have to multiply 1 with 10 and 2 with 11. That is how we can eliminate. So 1 had 11 I1, so multiplying with 10 will give 110 I1 plus 50 I2 plus equals to 20. Equals to 20. And if you multiply 2 with 11, then what you will get? You will get 110 I1. 110 I1 and then 21 into 11. 21 into 11 means 21. So 231. So 231 I2 equals to 22, right? Why 22? We are multiplying with 11, so 11 into 2 is 22. Now just do the substitution method, so they cancel, so you get minus 231 plus 50 I2 equals to minus 2. Okay, 20 minus 22 minus 2, so this will be minus 181 I2 equals to minus 2, so minus minus cancel, so I2 will become 2 by 181. Now you can put this value back to one of such equations to calculate I1. So I1 can be calculated any of the equations, and if you calculate it, you will get I1 to be 32 by 181. I am not calculating. Now you can understand that even though the expressions are slightly easier, calculations is very tricky in these cases. You will find it difficult to solve these questions. There are a lot of concepts involved in this case, and if you make any mistake in one of the steps, you might not get the marks. Okay, so that is why I avoid circuit diagram related questions. Okay, you have to draw the circuit diagrams first, you have to analyze it correctly, then you have to apply mathematical application as well. So don't waste your time for circuit diagram related questions in your PU board exam if you are not well prepared. Now this is a lot easier question, so we will see this as a method. If you follow the method, you can answer any questions related to AC. So the series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and resistor of resistance 40 ohm. If the AC source of 2 volt 50 Hz is present in the circuit, find the impedance, also find the resonant frequency of the circuit. So first method, obviously methodical means step by step process. First we will calculate XL. XL is 2 pi FL. Okay, the values are not super good in this case as well, but you have your calculators, so you can use your calculator to find it. Frequency is given 50. Okay, most problems, these first two lines are same. Okay, this first values are same. Okay, 3.1. If you are using a calculator having the value of pi, you can directly insert the value of pi in that. Okay, into impedance is 5, sorry. So impedance is 5, so what will be the value? 50 into 2 is 100, 100 into 5 is 500, 500 into pi. So 500 into pi means 500 into 3.14, that will be equals to 1570, approximately 1570 ohm. Okay, now XC will be equals to 1 by 2 pi F into C. Okay, so XC, next part is calculate XC. XC is 1 by 2 into 3.14 into F is 50. Only thing you have to careful about here, generally capacitances are given in microfarad, picofarad, whatever it is. So microfarad means 10 to the power of minus 6. Okay, 10 to the power of minus 6. So this 10 to the power of minus 6 will move from here and it will move to the where? It will move to the numerator, top, and it will become plus. So that is only thing that you have to be careful about while solving these questions. Okay, I think it will be 159 or something. I don't remember the value. You can calculate this exact value. Okay, and then the impedance is given by square root of R square plus XL minus XC whole square. You have a calculator. If you are using calculator, these are the easy questions. You can put the values. R is 40 ohm, XL we have calculated, XC we have calculated. Put the value and you will get the answer. Okay, I will show you the answer, not right now. Now what is the resonance frequency? Resonance frequency is basically 1 by 2 pi square root of L into C. Okay, so that is 1 by 2 into 3.14 and L is 5, C is 20 microfarad, 10 to the power of minus 6. So 5 into 20 is 100. So 100 into 10 to the power of minus 6 is 100 into 6.28. 100 into 10 to the power of minus 6 is 10 to the power of minus 4. Right, so 10 to the power of minus 4 or 10 to the power of minus 4 square root is basically 10 to the power of minus 2. So it will go up and it will be 100. 100 divided by 6.28, it will be close to 19 hertz. Okay, let's see the answer. So the answer is 1412 ohm. 1412 ohm, and it is not 19, sorry, my mistake, it will be 16 hertz. The answer will be very close to 16 hertz. Okay, that is 15.9. You can use the calculator to calculate the exact value. So these are much more easier questions, step by step problem, and you can solve it faster as well. As you see that all the problems you have to find with Excel, calculate XL, calculate XC, calculate impedance. In some cases they will might ask you to find the power factor. Okay, so power factor methods also we have solved in the question in the numerical section. You can check that out. So these are the very common questions to answer. So electric field problem was very easy. Again we will see that this is also an easy question. So an object is placed at a distance 0.3 meter from a convex lens of focal length 0.2 meter. Find the position and nature of the image formed. Also find the distance through which the object should be moved to get an image of linear magnification -1. So they try to always confuse you. So you have to practice this kind of question. So in this case object distance is given. Object distance is always negative. Focal length is given. Focal length for convex is always positive. Okay, convex lens, convex mirror, focal length for convex, if you see, focal length is positive. Object distance for any lens, any mirrors is always negative. So now what is the equation? Equation is 1 by V minus 1 by U equals to 1 by F, or 1 by V equals to 1 by F plus 1 by U. So this is like resistances in parallel. So we can say V equals to UF divided by U plus F. Okay, so this is the formula that we will use to calculate V. So U is minus 0.3, F is 0.2, minus 0.3 plus 0.2. Okay, so this will become, what is the value? V will be equals to minus 0.06 divided by minus 0.1, minus minus plus, and it will cancel, it will be 0.6 meters. So the object distance will be image distance will be 0.6 meters. Now sign of this image is positive. So a sign positive means for a lens, sign positive means the image is forming on the other side. So other side means definitely it's a real image, right? And because it's a real image, it must be inverted as well. Right? Now how much distance you should move it to get an magnification equals to -1. Now magnification -1 occurs only when the object is placed at a distance 2f. So object is placed at a distance 2f magnitude wise. So object distance, when it becomes equals to 2f, we get the magnification -1. So what should be the distance in that case? So distance in that case should be 2 into 0.2, that is 0.4. So the displacement must be equals to, this is the final position, initial position was 0.3, so just find the difference between them. So it will be 0.1 meter. And which direction we should move? We should move away from the lens, because object was between so this is 0.2, this is 0.4, okay, and object is somewhere here. So we have to move the object away from the lens, right? So away from the lens. So as you can see, this is a much easier problem to solve, even though the concept might require a few concept. For example, this second part of this question where they asked you what will be the how much distance you have to move it to get magnification -1, but you can still figure it out. These concepts you have studied in your class 10th as well, if you have studied the chapter, right? But current electricity, in my opinion, is not worth to put too much trust on that. So this is the last question of this model question paper. If you have any doubt, don't forget to mention that in the comment below, and if you like this video, don't forget to give it a thumbs up. I'll be back with more questions for your PU preparation. Till then, bye.